Okay, Redox, that is chapter number 6, and we are going to talk about, oxidation and reduction. This redox is combination, the redox reactions are the combination of basically two reactions. One are said to be oxidation reaction and other one are said to be reduction reaction. First of all, what are the oxidation reaction or what is the simple oxidation? What is the simple definition or definitions of oxidation? Number one, basically the loss of electron is said to be oxidation. Number two, gain of oxygen is said to be oxidation. Number three, loss of hydrogen is called oxidation. Number four, increase in oxidation state or oxidation number is called oxidation. So once again, minus electron, loss of electron is oxidation. Addition of oxygen is oxidation. Minus hydrogen, loss of hydrogen is oxidation. And again, increase in oxidation number or oxidation state is said to be the oxidation. Now, what is the reduction? It is a reverse of oxidation. Number one, gain of electron is called reduction. Number two, loss of oxygen is called reduction. Number three, gain of hydrogen is reduction. Number four, decrease in oxidation state is also said to be reduction. So basically, whenever any molecule, any species, any atom, if it is going to gain electron, if it is gaining electron, it's going to reduce. Minus oxygen or losing oxygen, it is said to be reduction. Any species, any molecule, especially organic molecule, when they are gaining hydrogen, it is said to be reduced or it is said to be reduction. And when it is going to reduce in their oxidation state, decrease or reduction in oxidation number, that is said to be a reduction. So these are the basic four definitions of oxidation and reciprocally speaking, reduction. So these two reactions are happening in a reaction. Overall, that reaction is said to be redox reaction. So any reaction that is composed up of reduction as well as oxidation, a reaction that is hosting two reactions. Number one, oxidation. Number two, reduction at the same time. The overall reaction, the overall that chemical change is said to be a redox reaction. Redox reaction. Red for reduction, ox for oxidation. Now the next, the basic thing is, what is the oxidation number or what is the oxidation state? Oxidation number or oxidation state, basically it may be a positive number or it may be the negative number that is appearing on an element of a compound. For example, in case of HCl, I'm talking about simple covalent molecule. In this case, this oxygen is having +1 oxidation number and this Cl is having -1 oxidation number or oxidation state. So numbers appearing on the element in a covalent molecule because of their difference of electronegativity. Because of difference of their electronegativity, that is said to be an oxidation number or oxidation state. Now let's see how to diagnose, how to find or how to assign these oxidation number to the different elements. Number one, how to assign the oxidation number? Number one, oxidation number may be positive and it may be negative, it may be zero, or it may be in fractions. It may be in fractions, right? So, oxidation number may be a positive integer, maybe a negative integer, maybe a zero, maybe a fraction. Next, number two, negative and positive number are assigned on the basis of electronegativity difference of the bonded atoms. As I told you in my previous example, HCl, this Cl is more electronegative. It is having almost 3.0 electronegativity and it is more electronegative, so it is having -1, and hydrogen is almost having 2.1 electronegativity. Its number is +1. Power of an atom to attack the shared pair of electron, that is said to be electronegativity. So these positive number and negative number are assigned on the basis of their nature of electronegativity. Cl is more electronegative, so its number will be negative. It may be -2, -3, or roughly speaking, but the number negative is going to indicate the more electronegative nature. The next thing is all the pure elements, noble gases having zero oxidation state. I mean, sodium metal, this is a solid. Iron metal, it's a solid. And same is the case, hydrogen gas, it's a gas, it's element. Nitrogen N2 is a gas, it's element. And Br2 is a liquid element. And similarly, helium is a noble gas element. All these pure elements are assigned, are said to be, are having zero oxidation state. If you're having the sample of only one type of element in your sample or in your examination, then it means that it is having only zero oxidation state or zero oxidation number. So the rule number one, once again, it may be positive, it may be negative, zero or a fraction. Number two, these negative and positive integers are assigned with respect to their electronegativity nature or electronegativity power. The next one is the pure elements. It may be a element, solid element, it may be a gaseous element, it may be a liquid element, but all pure element plus noble gases, these are also elements, are having zero oxidation state. The next one is hydrogen. Hydrogen is usually, you can say 90% or 90, more than 90% cases, it is having +1 oxidation state, except when it is making ionic bond. Except when hydrogen is making ionic bond. For example, this is a sodium hydride. And sodium hydride, here this is the hydrogen and it is having -1, this is sodium, this is +1. In this case, when it is attached with a metal, so just when it is having the metal, no other non-metal is present over here, so it is having -1. But usually, in most of the cases, in all covalent compound, it is fixed. It is fixed in all covalent compound. Its number is equal to +1. Now come towards the next one, group 1, group 2 and group 3. These are the metals. They are showing respectively +1 oxidation state. All group 2 members show +2 oxidation state. Group 3 members are showing +3 oxidation state or oxidation number respectively. So if you are dealing with the ionic compound, then in case of ionic compound, yes, you can assign the oxidation state or oxidation numbers +1, +2, +3. These are strictly according to their group numbers. They are according to their group number. Group 4 elements are basically, they are showing variable oxidation state. I will explain in the section of organic portion or organic compound later on. Let me go ahead. Let me explain one thing more. Let's see over here, it's a carbon, it's also a carbon, but these two carbon are basically different carbons. They are having a different environment. It is attached with the 3 hydrogen and 1 carbon. This carbon is having 2 hydrogen and 1 oxygen, 1 carbon. So they both are having different environment, different atoms attached to them. So they are having different oxidation state. Their oxidation number will never be equal because their neighbors are different, their environments are different. So definitely there is a different method that is not the simple or the normal method. Now, group 5, group 6 and group 7 elements, they are also showing variable oxidation state like transition elements. Group 5, group 6, group 7 showing variable oxidation number or oxidation state. And group 5s basically, it starts from -3 to +5. So -3, -2, -1, 0, +1, +2, +3, +5 till +5 because it is having overall 5 electron in the last shell. So they can show up to +5 oxidation state. Nitrogen, that is the member of this group 5 element, it is basically usually having negative oxidation state except two cases, when N is attached with oxygen or when N is attached with F. In these two cases, it is having plus oxidation state, but except all other conditions, except all other, especially all other, in all other covalent molecule, it is going to have a negative number. So nitrogen is assigned negative number except when it is present, it is bonded with oxygen or it is bonded with fluorine atom. The next thing is about group 6 elements. They are again showing basically variable oxygen state, but I'm concerned with oxygen. Oxygen is showing usually, in most of the cases, it is showing -2. There is only one case of +2, that is OF2. In case of OF2, I told you F is always taken negative. 2F mean normally 1 negative for 1F, so 2 negative for 2F, and so to balance, to equalize, to making sum equal to 0, I will put +2 over here for oxygen. So the combination, the sum of these both boxes is equal to 0, as it's a neutral molecule. So only OF2, only in OF2, oxygen is showing +2. सिर्फ एक exceptional case है. This is an exceptional case. Otherwise, it is mostly showing -2. Sometime it is showing -1. Sometime it's showing -half. -half is not in your syllabus, in Cambridge syllabus, but in peroxide, when it is mentioned in the question that it's a peroxide, in peroxide, the oxidation state is -1. Oxidation state is -1, usually -2, exceptionally +2, -half is not in your syllabus. अगर आपको डाउट हो कहीं पर, then you can check the other one element. For example, it's a barium. Barium oxide, BaO2. BaO2. These are the two elements I'm going to divide into two parts. This whole molecule can be divided into two parts because there are two types of elements lying over here. So barium belongs to group 2. Group 2 are having fixed oxidation number, that is +2. So to make sum equal to 0, I will have to put -2 in this box. This answer of -2 is for 2 oxygen. For 1 oxygen is equal to -1. Whenever you are going to find the -1, then it is said to be peroxide. These are called peroxide. These are not the normal oxide. And same is the case superoxides, but they are not in your syllabus. So superoxide could anything. Sure, leave it. Just concentrate on peroxide because you are going to have some peroxide in your syllabus as well. Mostly, in the most of the cases, oxygen by default is going to show -2 oxidation state. जब आपके पास कोई और ऑप्शन नहीं है, जब आपको बाकी एलिमेंट का पता नहीं है, for example, here is MnO2. This is manganese. This is transition element. It is also having a variable oxidation state. Then you will put oxygen equal to -2 by default. -2 multiply by this 2, that is equal to -4. So this box is having -4 number oxidation number. So according to this -4, this manganese will show +4 to make overall sum equal to 0, as this MnO2 is a neutral molecule. It is not an ion. It is normal, simple, neutral molecule that is having overall 0 oxidation state. This overall molecule is not having any number, any negative ion or positive ion. It is having 0 number. So this is the way to find the oxidation state of the different element. And as I told you, usually it is -2. Group 7 is showing -1 usually, but it can change from -1 to +7. Again, F is always having minus number. Cl may be the positive. When Cl is attached with oxygen, when Cl is attached with the F, in these both cases, in these two cases, it may be having the positive number, but otherwise it is having a negative number. The oxidation number of Cl is usually negative. However, it is going to have the, ionic compounds or covalent compound. But when it is having oxygen in its proximity or fluorine, then its number may be 1 plus, 2 plus, 3 plus, 5 plus तक या more than that of 5 plus जा सकता है. तो Cl का अक्सर आंसर, यूजुअल आंसर नेगेटिव है. बट अगर OF ये आपने याद रखना है, when it is having oxygen and fluorine in its proximity, then obviously its number will be in positive integer, and it may be plus 1, plus 2, plus 3, plus 4, plus 5, and till plus 7, and so on. Now the next one is a transition element. They are having variable oxidation state. कोई fixed number नहीं है, देखना पड़ेगा. There is no easy way to predict. The last one, you will have to memorize these negative ions partially. NO3 overall answer is -1. As you have seen that NO3, 1 nitrogen, 3 hydrogen as an ion, 1 negative ion. So overall NO3, nitrogen and 3 oxygen, overall they are making -1 oxidation state. This charge on the ion is also equal to oxidation state or oxidation number. This is oxidation state of the whole ion. Same is the case. The combination of 1s and 4 oxygen is going to born 2 negative oxidation state. ये पूरी oxidation state एक molecule की है. PO4, the whole molecule is showing -3 oxidation state. Same is the case. OH, the combination is going to make -1 oxidation state. Sometime ऐसा होता है कि sometime the nitrate ion is present in the reactant as well as in the product. या generally speaking आपको अगर just nitrate ion के साथ वाला देखना है. For example, Cu NO3 twice. The shortcut is, this is nitrate. It is 2 in number. So 1 nitrate is equal to -1. So in this box, its overall complete oxidation number will be equal to -2. So to make sum equal to 0, you will put +2. So you can find the oxidation state of copper. तो इनके साथ जो मेटल आयन होते हैं उनका ऑक्सीडेशन स्टेट आप मालूम कर सकते हैं इन दिस वे. उनके साथ क्योंकि दे आर हैविंग दे आर हैविंग द फिक्स ऑक्सीडेशन स्टेट. अगर NO3 है तो -1 होगा, एक शॉर्टकट भी है. SO4 होगा तो 2- होगा. SO3 होगा तो वो भी 2- होगा. कुछ आपको आने चाहिए फॉर द सेक ऑफ शॉर्टकट यू कैन से. PO4 3- होगा. So with the help of these numbers you can find the oxidation state of the rest of the element. Now come toward the next one. Now just I'm doing 3 to 4 example. That will be all for today. And now the example number 1. Oxygen, potassium, manganese, and oxygen. We are sure about potassium. It belongs to group number 1. So I will write +1 over here. I'm sure about oxygen in this case. It is not with fluorine, right?
So it's -8.
Good. It's a -8 because 4 into -2. So
Manganese is 7.
+7. So to make sum equal to 0, I will write +7. And here's the answer. Good. Now come towards NaClO3. Sodium is obviously fixed +1 because it is a member of group 1 element. Oxygen is -2. 3 into -2 is equal to -6. To make sum equal to 0, as you have seen, there is no charge, there is no any ion.
+5.
So Cl is equal to +5. So you have seen that Cl is making +5 in this case. So come towards HNO3. Again,
-6.
we are knowing about oxygen, it is -6, and hydrogen, it is +1. To make sum equal to 0, it will be equal to +5. Now come towards 2 other molecule, H2SO4. Again, we are sure about hydrogen, we are sure about oxygen. Oxygen is equal to -8, 4 into -2, and hydrogen is equal to +2. So overall sum, there is no any charge on this molecule. So sum must be equal to 0. So I'm writing +6 over here. So this sulfur is having +6. In this case, potassium dichromate, again, sum must be equal to 0. 7 oxygen, I'm going to multiply -2, I mean -14 over here. 2 potassium plus 2 over here. And there are 2 chromium. So I'm writing +12 to make sum equal to 0. But this is the answer of 2. So 12 plus 12 divided by 2, 1 chromium is equal to +6. So whenever you are asked to find the oxygen state of an element, you will be bound to find with respect to one element, So the actual answer is +6. That's all about today, man. Thank you very much. Bye.